Um, yes, today we are going to discuss POS statements called product of sum. Uh, we have discussed sum of product statements and we saw how to simplify them. So then we can see how POS or product of sum statements can be used. So I would like to put the topic here as product of sum called POS, that is product of sum. What is the difference in between these two? Earlier we have discussed SOP, sum of product. And today we are going to discuss POS. SOP statements. Let's see one example here. I have taken one example for a SOP statement. I say Z equal A by B and C or A and B by and C or A and B and C as an example. I can show another example. Like says Z equal AO BO C and AO B bar and C and A bar B C. Now you can see the difference. SOP sum of product expressions are always I can explain like this. We have output of AND gate. So we have n terms of products. Now we are taking the sum of the products. All the outcomes of AND gates are moved to a particular OR gate. OR gate, we say this combination O, second combination O, third combination. So final outcome is a OR gate, but there are 3 AND gates. POS is another way of taking the output. In POS statements, we have OR gates. Outcome of OR gates, see A, O, B, O, C is a one OR gate. It goes to an AND gate finally. So here what is happening, all the some terms are moved to an AND gate. This method is also called max terms. Say max terms. Here there is a word called min terms. Right. Basically, in a truth table, if the final outcome is 1, so we get the ones using SOP statement. In a particular truth table, if the final outcome is 0 in these terms, it is 0. So we have to change the, actually we have to get the complement of, SOP statement here in order to get the outcome. So this is the most popular method of taking the output. Second method is also used for taking output. So that's why the POS. In our syllabus, they have introduced POS. So we think about POS statements also. Right. Let's see how we get the POS here. I would like to show you one example. I take an example. I need a truth table here. We have A, B, C, and F. Now, there are 4 zeros, 4 ones, and then 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 1, 0, 1, 0, 1, 0, 1. This time I have a output like this. This one is 0. Here output is 1, then 0, again 0, again we have 0, 1, 1, and 1. This is the outcome. Now, you know how to write the SOP statement. If the output is 1, we always take the Boolean combination here. So then we can fill the equation. We can get the Boolean equation. But today we are going to write a POS statement. If the output is 0, we are trying to get the Boolean equation. So what is happening here? Actually, if we are going to solve a problem, we get the relevant answer for 1. But there is a way of saying all the non-zero, these are the 0 combinations. We can say all the non-zero combinations. If the outcome is not equal to these 4 values, then we can get the answer. So if you get the complement value of these places, you can get the same answer. So here A bar and B bar and C equal 0. Again check A bar and B bar and C bar is 0. But we get the complement of it. If it is A bar, we say A. If it is AND, we say O. Then we have B bar, we say B. If it is AND, we say O. This is C bar, so we say C. Now this is the way of getting the complement value. This is A bar and B bar and C bar, the complement of it, AO, BO, C. Then we don't need this one, we need this one. Here, A bar, we get the complement as A, and is changed as O. We have B here. Now complement is B bar. We have C bar here with O. We say C. This is the second one. The third one can be written easily. We say we have A bar, so A, and is changed as O. We have B here, it should be B bar, then O. C here should be C bar. Then we can easily find A means A bar, O, B, or C. Why? We have B bar and C bar, it has changed as B, O, C. Then we get the POS statement. We say F equal A, O, B, O, C, and A, O, B bar, O, C, and A, O, B bar, O, C bar, and last one here, A bar, O, B, O, C. This is the way of writing the POS statement. So you can get an idea about taking the POS. Earlier we got SOP statements. If the output is true, we take this is the output. But this time we say if the output, if the final outcome is 0, we are going to get the complement of this. We say we can get the output for all the ones. This is the first method. We can get the output for all the complemented values of 0. All the complemented values of 0. So that is the second way of taking the output. That is called POS, product of sum statement. Right. Now we are not going to simplify this statement this time. This is a very big statement, so no need of thinking about the ways of simplifying, right? Because we have actually done several exercises for simplifying SOP statements. So I don't ask you to simplify these statements. If you get the Boolean equation, that is enough, right? So that is enough. But one important thing is there is a way of converting a SOP statement into a POSO, POS statement into a SOP. That is important. So we are going to see one example. Right. This time, this is the next topic. I take one SOP statement. So topic is actually transforming. Now we are going to transforms SOP statements. We say SOP into SOP into POS. Now, sum of product equation can be converted. Sum of product equation can be converted into product of sum equation. I take one example. I have a statement called F equal En B bar O Bn C bar O A bar and C. Now I want to do something. First of all, think about the statement given here. This is a sum of product statement. It is easy. Everybody can understand that statement. But it can be a simplified one. That's why we have three variables here. We have three variables here. So it can be a simplified one. Otherwise, we cannot see like this. But my aim is to convert this statement into a POS. First thing is, if you want to convert this statement into a POS statement, or the product of sum statement, you have to get the complement of the entire statement. So what you are going to do, you write the statement again. You write A and B bar O, B and C bar O, A bar and C, and you have to draw a full bar here. That is an over bar. You write what you have to do. Get the complement of whole Boolean equation or expression. Get the complement of all Boolean equation by drawing an over. This is the first step. We want to get the complement of the entire statement. So it is easy actually. You are going to draw an over. After drawing an over bar, what you can do, you can apply De Morgan theorem. This time De Morgan theorem is useful. That's why earlier I told you there are several laws. De Morgan is one important law in your exam. So then what you can do, you can apply De Morgan here. Now, De Morgan theory says breaking the overbar or breaking the whole bar here from where with the main operators O. With main operators we are going to change it. So we break the bar here. After breaking we have A and B bar under that. Then what we see here, we are moving to AND. We change the O. So then here even B and C bar, we have the AND statement, and then we say A bar and C here, that's a full bar. So I broke the O bar with main operators, and so then I changed the operator and then broke the line. Then after that we are within 3 AND with 3 AND operators. Now what we can do, we have another situation. There we can apply the De Morgan law. Now you have to write here as you applied De Morgan law. De Morgan law. You apply the De Morgan law. Then after that again you are going to apply the De Morgan law. So what you can do, have brackets here. You break the line, so a bar and the bar here. Change the operator, it should be O. And here even, see there is 1 bar here, but here 2 bars. And we can simplify this part also. So how? We have B, O, C, here double bar, here single bar. And again we have A here, so change the operator and bars like this. So De Morgan theory is used for the second time. Again De Morgan law. Now what we can do? We have some situation with double complements. So we say A bar O, here double complement law, so it will become B. And then AND B bar O C. Why? Again we have a double complement situation. And we have AND, say A O C bar. This is the final one. Now if you need, you say this is actually inverse law or the double complement. You say inverse law. Otherwise the double complement. This is the final answer. So with De Morgan theorem, there is the ability to convert the entire sum of product statement into a POS statement. Now we have a POS. We say A bar O B and B bar O C and A bar O A O C bar can be used to take the same output. One method is taking the output by using the SOP statement. If you convert the SOP statement into a POS, you can get the output by using the POS statement also. Right. This is the way of converting. It is easy actually. Uh, the thing is, we are using De Morgan law, and sometimes the double inverse law here, the double bars are removed. So we can do it easily. Right. Then if you have a POS statement, suppose you have a POS statement, you should be able to convert back into a SOP statement. These are actually exam requirements, converting these things. They ask questions based on such statements. So we are going to see how to convert the same statement again up to a SOP. Right. Now I have a POS, product of sum statement. I take that statement, it would be like this. This time we are going to change the topic again, transform POS. We say transform POS into SOP. POS into SOP, converting. So I have a POS statement. It says A bar OB and B bar OC and AO C bar. Right. Now I have the statement. This is a POS statement. Now the first rule is taking the complement value of entire Boolean statement. Right, let's try. I say A bar OB and B bar OC and AO C bar. I need to take the over bar. Right. Then I write. I say get the complement of all statement, that is Boolean statement, by drawing an overbar. By drawing an overbar. It's the first style here. Drawing overbar. Then after that, we are going to apply the Boolean De Morgan theorem. So main operators are AND. So we are going to change it. So we break the bar. Under that we have A bar B. Here operator has changed as E. Then we have B bar C. We have the overbar. and the operator. Now we have AO C bar, and the operator has changed and the line has broken. Now we have used De Morgan law. This time we say this is De Morgan law. Again, now we have changed all the main operators. Again, we can apply De Morgan law within these places. So we are going to apply the De Morgan law. Now it should become A and B here. Then O. We can break it. So B double bar and C bar. O. A. Break the line with the operator. So it should become and A double bar with, A bar with C double. Again, De Morgan law as used. De Morgan law. Now what we can do, we are going to use the double inverse law. So double bar is removed. We take A and B. I don't use the dot here. A and B bar. O, B and C bar. O, A bar and C. This is actually a double complement. So inverse law. With the help of inverse law, we have taken the previous output. A and B bar O, B and C bar O, A and C bar is the SOP statement. So we have already get the POS statement of the given SOP equation, and now we could get back the previous statement again. So POS, point of product of sum statement has been converted into SOP again. So this is the way of converting these statements. First thing is you get the original statement and draw an overbar to the entire statement. Then what you can do, you can apply De Morgan theorems. At the last step, you have ability to remove in all the double complement situations. Then you get the final. So it is easy. In exams, they will ask you to convert. They will ask you to get the POS or get the SOP statement. In most of the exam questions I have seen, they ask you to get the SOP, not the POS. So after getting SOP, they may ask you to convert it into POS. Those conversions are important. Right. Now I think you have taken an idea. So we have discussed very important things in this lesson. With the Boolean laws, we could simplify all the statements. So we use several laws and we simplify. We try to we tried to do some long Boolean equations. So there we applied different statements, actually, different ways of changing them. Now what we are going to do, we have to see some different situations. Uh, Actually, in exam papers. So I would like to show you one example here. See, you will now have one example here. Now there is a Boolean equation, but they have shown you the logic gate circuit also. I draw the circuit here. There are three inputs, A, B, and C. A input values to O gate. Here O gate. That is the input here. From B, there is an input to the O gate. So outcome says A or B. Outcome is A or B. And with here we have another O gate. Another O gate. B input a value to the O gate, and C come here and input something to O gate. So outcome can be B, O, C. C remains here, and C comes to forward. Now all the outcomes are going to an AND gate. Here we have an AND gate. This is AND gate. So this time A or B, and we have B or C, as well as we have C. They all three combinations are moved to the AND gate here. So what is the outcome? We can write the outcome now. With the AND gate, we have A or B and B or C and C. See, the reason C is moving. See, A or B and B or C and C. According to the given logic circuit, we see the output. That is the output. Now, when you see the style here, when you see the final equation, you will understand it as a POS. It has a product of sum output, because A, O, B and B, O, C and C, like that. But here the third one is a direct input. Remember, this is a direct input. Right. So without using O gate, they have send an input to the AND gate. Now anyhow, this statement is okay. This is the final one. What is important? Examiners may ask you to draw the truth table of it. In most of the exams, they give you scenario. So after reading the question, you understand the possibilities. So how the values, how input and output occurs. So then it is easy to draw the truth table. But this time, what is the difference? They have given the logic gate circuit, and you are asked to draw the truth table. Right. I would like to show you how to draw the truth table here. Now the expression is here. I keep it. I delete the entire logic circuit and see the statement here. AOB and BOC and C. Now in order to I put the statement here. F equal AOB. This is a statement. And BOC and C. This is the statement. AOB and BOC and C. Now I wanted to get the truth table from the given. I want to take the truth table from the given expression. So what are the inputs? A, B, and C. A, B, and C. And other combinations are there. AOB. So I take AOB. Another combination. What is that? BOC. BOC. If I have AOB and BOC, what we can do, we can get AOB and BOC and C. It can be the final outcome. So I have 4 zeros, 4 ones, 2 zeros, 2 ones, 2 zeros, 2 ones, 0 1, 0 1, 0 1, 0 1. Then AOB 0 0 0 0 0 again 0 0 1 1 0 1 1 1 0 1 1 0 1 1 1 1 1 1. Then you know O gate. It should be O. BOC 0 0 0 0 1 1. Because of O gate 1 0 sorry 1 0 1 1 1 1 0 0 here 0, 0, 1, 1, 1, 0, 1, 1 more 1 here, 1. So I have taken these three. Now the final statement says AOB and BOC and C. All of them are AND gates. Now we have AOB here, BOC here, and C. So we check 0 into 0 into 0. So 0, 0, 1 into 0, 0, 0 into 1, again 0, 0 into 1, 0, 0 into 1, 0, 1 into 1, 1, 1 into 1, 1, 0 into 1, 0, 0 into 1, 0, 1 into 1, 1, 1 into 1, 1, 0 into 1 means 0, 0 into 1, 0, 1 into 1, 1, and then 1 into 1, 1. So we have taken the outcome here. This is the output. So we have taken the truth table back. Then after that, you can use the same truth table in order to show the final outcome with the 3 input combinations. So as I told you, in most of the cases, now this truth table is okay, it is correct, but I would like to show you another table. Here, see the second truth table, you get the idea here. A, B, C, and the outcome is F. I will say 0, 4 zeros, 4 ones here, 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 1, 0, 1, 0, 1, 0, 1 here. Now this is the truth table. This is the actually input combinations, and there are 3 input combinations, and this is the final output. So I say the F 0. I use this one, this part 0 here, 0 again, 0. I have 1, 0, 1, 0, 1. I have the output here. When I check the output for a SOP statement, right, for a sum of product statement, I can get once it says A bar and B and C. A bar and B and C. What about the here? A and B bar and C. A and B bar and C. Here even A and B and C. A and B and C. Now say F equal. F equal. It should be A bar and B and C, O. A and B bar and C, O. A and B and C. This is the sum of product statement. Sum of product statement of the given truth table. So what I wanted to tell you here, if you get such a statement in exam, you get statement, you get only the Boolean equation. So you can put all the input and output combinations into a truth table and you can get the final outcome like this. This is AOB and BOC and C. So after taking the output, you can show it as A, B, C are the inputs. This is the final outcome. But don't worry about we have AOB, and like that. So it can be the zero situations. We don't need zero situations. We see the min terms because min terms is so smaller. So this is the output. So output is written in min terms like this. By using min terms, you can write the output like this. If you want to simplify this one using the Boolean rules, you can do it. So you can actually try to simplify the statement and you get the Boolean statement. Then you can simplify it. One important thing is how this statement says we need A and B and C, right? So if you want to convert it into a POS, you have ability to draw a overbar here. Then you convert the entire statement into POS. Right? I mainly considered if you have a Boolean statement, it can be a simplified one, but with the assistance of a truth table, you can find out an entire statement like this. This is a full statement, right? So you have to learn a lot of things from the given example here. So remember, if you have a Boolean equation, you can put it into a truth table like this, and then after that you get the final outcome easily. So both are same. In the exam, we expect such a table. Right? If they ask you to draw the truth table by giving such a statement, you have to draw the second table. But if it is difficult to draw it, you can draw the first table and then you get the output and then you show it. So this is not the POS statement anyhow. This is a POS, but after taking the output, the truth table says this is the output. So it has 3, 4, 5 zeros. So max term is larger, but we have 1, 2, 3 ones, so min term is smaller. So it is better to take the min term statement here. Now what are the things we can do? We can convert the sum of product statement, this statement, into POS, right? So there are various possibilities, right? Okay. I think you get an idea about these things. Now we have to discuss most important things in this lesson. In the next session, I would like to discuss Karnaugh maps. So Karnaugh maps is another way of simplifying Boolean expressions. Before this, we have used the Boolean laws to simplify all the Boolean expressions. Right, so we stop the lesson here. Then we will start K-maps with the next lesson. Okay.